Let's go for it. All right, well, study set 8, and I'm not alone, as you can see. And look, more people are coming. So let's do it. So aldehydes and ketones. And it looks like we're deciding if we want to name them or not. So A is a ketone. So it is an one, so we can name it. It's just 4 across. So technically it is just butanone. And why don't I say 2-butanone? You guys are here. You should get a bonus point.
Because it can't be at 1 or else it'd be an aldehyde.
Yes, and it can't be at 3. What would happen if it was at 3, Ezra?
It'd become a 2.
Yeah. Yeah. So on when there's only 3 or 4 carbons for a ketone, we just write the name. So it's butanone. All right, on B, it is neither. This is an ester. And we're not naming esters until after the celebration too. So next week, we're going to learn about esters. So for right now, I want to make sure you recognize this is not a ketone. And that is because of that extra oxygen there. So when the oxygen and the double bonded oxygen are on the same carbon, that makes it a new category. All right, C is an aldehyde because it's at number 1. So 2-methyl. We do need to number the methyl because it could have been at 2 or 3. And then butanol. So make sure that ending is AL for aldehyde. We never put a number for aldehydes because they're always at number 1. And then on D, this is an aldehyde also. So when you see that CHO, that is number 1, 2, 3, 4. So we have a 3,3-dimethyl. And all of these were butes. So butanol. All right. Any questions? And I'm tickled pink that there are several of you here. So thank you. And we can name them, but let's see. B is carboxylic acid. C is an aldehyde, and to name it, I would have to name this as a side group. So I know it said you didn't have to name it, but I'm going to name it anyway because somebody always asks. So I would call it a cyclohexyl. So the YL tells you it's a side group. And then 1 carbon, you guys would all say methanol. Does anybody remember the other name that everybody else in the world calls it? So cyclohexyl methanol, if you're going to name it. Does anybody else remember what a 1 carbon aldehyde is called? It's the stinkiest one, I think. Formaldehyde. So formaldehyde is the same as methanol. So cyclohexyl formaldehyde or cyclohexyl methanol. I mention that because I'm pretty sure you've all heard the name formaldehyde before. And probably nobody's ever heard the name methanol because only introductory chemistry students would call it that. I actually had a student one year who did her paper on formaldehyde and presentation. It was one of the best presentations I ever had. She was actually in the church choir, had a beautiful voice, and she did a song, and it was hysterical. All right, and then A and D are both ketones, so I'm just going to write own. A we could name. We're going to name it. This is the question that several of you had on the worksheet. So I'm going to name it the old school way. So that bit that I circled, you just say that's the ketone, including that carbon. And then you name each side alphabetically. So we say cyclohexyl. So similar like an ether, but that 1 carbon is part of that word ketone. So cyclohexyl ethyl ketone. And then D is a dione because it's got 2 ketones. And my best guess, since I'm guessing, obviously you would not have to name one of these, is cyclohexane dione. And I would assume you have to number because the double bonded O could be anywhere. We do not use para though. So we'd have to say 1,4-cyclohexane dione or cyclohexadione. Why can't we use para?
Because it's not a benzene.
It is not a benzene. Thank you, Christy. Benzenes are flat, and so they would come out across from each other. Cyclohexanes actually, they make like this boat. They make this curve, and so they're actually both pointing up above. All right. So we're gonna name more. Naming's good. Your celebration, that's the first page, is the drawing and naming. And we'll do practice for that. All right, so aldehyde. So 1, 2, 3, 4, 5. So number, use your colors, number. And you'll notice we seem to always draw our aldehydes over on the right side. It's just a habit. It doesn't matter to me when you draw them if you make your number 1 on the left or the right, but they are often drawn this way. All right, so 4-methyl pentane. We do want that AN there to show it's fully saturated. On this one, either way we go, we get 4. So 1, 2, 3, 4, and at 2, that is an ethyl, so 2-ethyl. Butanel, so butane, and then Al. Let's see, and then C, we would say ethanol. And this side group is a phenyl. Now, kind of back to the question I'd asked earlier, if you put the 2 there, that's fine. Oh, I guess, yeah, it can't be at number 1 because there's no room for it at number 1. So it technically does not get a number. One of the key things with an aldehyde, now that you've seen them a little bit more, they always, because they're at number 1, they have that hydrogen attached to the carbon that has the double bonded O. And that's actually key. That's what's going to allow it to be oxidized. Yeah. Just more for your information, a 2-carbon aldehyde, actually everybody calls it acetaldehyde. It's a common name, but that's what everybody goes by, 2-carbon, and it's because 2-carbon acet, that's actually the word for vinegar. And so when we get into carboxylic acids next week, we'll run into that. All right, so this one's just 4, so butanol. And then ketones. You have to number, so the double bonded O is at the lowest number possible. So 1, 2, 3, 4, 5, 6. And we definitely want a number. So 1-hexanol. I'm sorry, 3-hexanone. I don't know why I just said that. So 3, set 3, and then hexanone. On B, this is going to be at 2, and that's at 4. So 4-methyl. And 2-pentanone. We do have to have numbers because either one could have been at a different place. The double bonded O, the ketone takes preference for being the lowest number, and aldehydes always take preference because they have to be at number 1. All right, on C, we're at 2 and 3, so it is a butanone. Again, you technically on butanones do not number the ketone because it has to be at number 2. And you if you said 3-methyl-2-butanone, that's fine. Again, technically the methyl number doesn't need to be there because it could only be at 3. All right, and then D, and then we're gonna rename all of these. So for D, it's right in the middle. So 1, 2, 3, 4, 5, 6, 7. So we have a 3,5-dimethyl. And, oh, sorry, 4 definitely needs a number, 4-heptanone. So it comes out symmetrical. They don't have to, but they could. We are going to rename all of these just because it was the most asked question during my office hour. They all can be named by their common name. So the trick to doing that, on A, circle the ketone, including the carbon, and you name each side. So this side has just 2 carbons, so that's ethyl. So I put the E there. And then this side has 1, 2, 3. So this is a propyl. So the other way to name number 1 would be ethyl propyl ketone. So do you have to do that? Not necessarily, but you might see me give you a name where it's named like that, like I did on the worksheet. Or it could be on the exam that you'll have a ketone and I might ask you to name it both ways. So it would be 1 point to be able to do it that way, but it's good practice. It's a point you can have. All right, on B, so let's circle our ketone. And on this side, we have a methyl. And on that side, that is an isobutyl. So the other name for B, I'll write it down here, is going to be isobutyl methyl ketone. All right, so hopefully you're starting to see this. C, circle our ketone. This would be a methyl. This is isopropyl. So isos do start with an I. So for C, our other name is isopropyl. I'm smiling because I usually have 3 boards that I get to write on, and I'm writing all over them. And my students, I'm seeing what I've done to my students for the past 10 years, or actually 5 years since we got rid of the book. And I give you the space to write on. And then we say ketone. So they always end with that word ketone if you do it this way. So isopropyl on one side, methyl. And then the last one is, anybody see what it is? It's the same on each side.
Are they sec-butyls?
They are sec-butyl. And so I'm going to assume you say disec-butyl. I don't know that they actually say the di when it's the same on both sides. So the reason I say that is because I was looking up something today and I found the name both ways. So it might just be sec-butyl ketone or disec-butyl ketone. But those are sec-butyls because they are 4 in a row. And it is at that second position, 1, 2, that it is attached. Any questions from that page? That was Jeremy, I'm pretty sure. All right. Halfway there. So, why they're higher boiling points is that they have the oxygen, they're polar. Because of that carbon double bonded oxygen. The alkanes are non-polar. So polar is always higher because of the pool. And then compared to an alcohol, alcohols have an H bond. So the H bond is always going to be our highest boiling point. And when we do practice, we'll see these. All right. So we are comparing ethanol and octanel. So you want to look, they're both aldehydes, they're both polar, they're in that category. So we have 2 carbons versus 8 carbons. So the higher boiling point is the 8 carbon, the octanel, and that's because it has more carbons, more surface area. Higher number of carbons or higher surface area. That's all I'm looking for on my explanations. On B, water soluble is the 2 carbon one, so the ethanol. And it's fewer carbons or lower surface area, so smaller surface area. So for solubility, we're looking for smaller. For boiling point, we're looking for larger. And then the last one, fragrant, larger. So for fragrant, you want more carbons, so the octanel. The more carbons they have, the more fragrant. The small ones stink awful. Formaldehyde and acetaldehyde, you don't smell them. All right, I'm smiling because I had to videotape your guys' lab, this week's lab, and I've really hesitated and tried to splice it because the fumes of that lab always get to me, and I'm sound pretty loopy in it. So, because I'm working with ether on several of the unknowns, and so I'm just pondering how much I've done that to my students over the years. So oxidation, we are aldehydes. So benzaldehyde, we'll draw it to start with. So the aldehyde, remember the O cannot be attached to the benzene. There's 1 carbon coming off. So you can show the carbon. If you show the carbon, then you do show the hydrogen. And what happens when you oxidize, hydrogen's probably good to show, is you still have the double bonded O, and what happens is an oxygen slips in there. So it gains an oxygen. This is now an acid, benzoic acid to be more precise. All right, on 1-butanol. So you can make your OH at either end, but it's at number 1 when we oxidize. So I did mention this, and we are now at that point 2 weeks later where we're going to show both steps. If you only showed 1 step, that's great. So we go from butanol to butanel. If you want to show the H here, that's great. It does keep oxidizing. Aldehydes oxidize, and it's because of that H. And so the number of carbons stays the same. The H is still there, but an oxygen squeezes in there. So we now have an OH and a double bonded O on the same carbon. So this is butanol, Al, and then this is butyric acid or butanoic acid, named for butter because that's where it was first isolated, I believe. So it is a 2-step. The other thing I wanted to mention here is oxidation means either losing hydrogens, which happened here, or you gain an oxygen. It's an or. And so in this first step, we see it lost hydrogens. In the second step, it gains oxygens. So on your celebration, if you ran into this, it's 1 point if you remember to show both steps. If you show both steps, you get 2 points. If you show only 1 step, you get 1 point. So it's not going to make or break you. But primary alcohols do go through a 2-step. They oxidize really easily because of the aldehyde. All right, isobutanol. So it's going to look like this. Did I do that right? I did not. guess I did. Yeah, so it's the same idea. It's a primary alcohol. I think I meant to do sec-butanol. That's all right. So we would go through 2 steps. And so the aldehyde on this side, there's our H, and it keeps oxidizing. I think I am drawing it in a funny way right now. So this is actually good. I drew it on this side. If you draw it on this side, on the left side, you need to make it a HO instead of an OH. So when we do an OH and it ends up on the right side, we write it as OH, but on this side, we want to show it as an HO. So the O is what is attached to this carbon. So this is the carbon it's attached to. All right, terbutanol is a tertiary. So tertiary alcohol is no oxidation. There's no place for it to, it does not have a hydrogen. So if we drew it, terbutanol would be our carbon. There's our 4 carbons, and this carbon is the one that has the OH. And that carbon, because it's already making 1, 2, 3, 4 bonds, it doesn't have a hydrogen. There has to be a hydrogen on that carbon for oxidation to happen. That's why aldehydes oxidize, because they have a hydrogen. They don't lose the hydrogen, but the hydrogen's important. Anyway, it's more information than you actually need, but that helps usually 1 or 2 students. So this one, we don't have to show the reaction. We're just doing toluenes. Toluenes is also known as what? What's the other name for it?
The silver mirror?
It is. And it is because you get a beautiful silver mirror. So in the video that I posted, it's only 17 minutes instead of 35 because I had to clip out where I went really weird, loopy. I actually show that, the silver mirror. And then I did the rest of the video and I left it in hot water and the whole test tube became a silver mirror. And I meant to go get it on Saturday and bring it home to show all of you. I was going to get it Wednesday and I'm like, oh, I'll just go Saturday. And I had no idea the campus would end up being closed for 4 or 5 days. So it is called a silver mirror because the glass just becomes completely covered with silver, the metal silver. So we're just looking for aldehydes. So this B is an aldehyde, and this C. So again, that carbon double bonded oxygen is at number 1, and it's that H. And then over here, this ABC, none of them, because they're all alcohols. So only aldehydes. I need a silver pen for this one, right? And I know some of you maybe have silver and gold pen. All right, and now we're gonna do Leo Gers. So we're gonna do reduction, which means adding hydrogen. So it's gonna gain a hydrogen. And so what you're gonna do is the double bond breaks open. So we have 1, 2, 3, 4, 5. You can draw the carbons or you can just do your zigzags. And where the double bonded O was, it's now an OH. So double bond breaks open and you have an OH. There is no other product here. So it's, we're adding the OH. And then this one, we have 1, 2, 3, 4, 5. So, and wherever your number 1 is, this double bonded oxygen becomes an OH. So we would get on the second one, 1 pentanol. And on the first one, 2 pentanol. So just wherever the double bonded O was is an OH, and that's it, unless there's any questions. All right, I'm gonna stop and we're gonna switch